Okay, so this is the working memory model. It's on page 48 and 49 in your textbook, and it's another model of memory. Okay, now Alan Baddeley and Graham Hitch designed this in 1974 because they suggested that actually the short-term memory that was explained in the multi-store model was far too simple. It was too simplistic. Okay, so rather than it being a single unitary store, they argued actually it's a much more complex process, and there was a lot more to short-term memory than it just being a box that you put everything into. Okay, so this is actually a model of just short-term memory by itself, but it does explain how it links to long-term memory as well. Now the main idea behind it is that short-term memory, rather than being kind of passive, is actually a working memory. Okay, so it actually holds everything that you're thinking about at that time, depending on the task at hand, and actually works with the task to help you interpret it and you work with it as well. Alright, so it's a multi-component system, which we're going to look at a picture of in a moment, and it's designed so that either the parts work either by themselves or together to tackle the tasks that you're going to see, and we'll come up with some examples of this while we look at it. Okay, so this is our model. You can see the central executive up there at the top, just like the executive of a company. This is this is kind of the master store. Yeah, all three of the different kind of sub stores are what we call slave systems. All right. So you can see information is passed from and to the central executive from all these different slave stores to our phonological loop, which is made up of the phonological store and the articulatory loop, which you can see obviously pass information between each other. This acts as our verbal rehearsal system. We also have on the right our visuospatial sketchpad. So this is where we are actually using visual information and spatial information to orient and kind of perceive the world around us. And we have our episodic buffer, which is kind of where we take all this information with time sequencing, we pass it, you can see there, to long-term memory. Okay. So the central executive by itself, like I said, it directs attention. That's its job. And these other sorts of what we call slave systems. This is the terminology you'll see in the exam, or the exam will want you to use. Okay, it's got a very limited capacity. Yeah, it's a key point of all of these different systems in the working memory model. So they will have very limited capacity. It can't hold that much. But because of this, in terms of the central executive, is that it can't actually attend to too many tasks at once. It's got a limited amount of attention it can dole out. So if you are in a position where you're using two different tasks that use the same store. So we know that the phonological store is where we store sound-based information. So when you're listening to me, you're using a phonological store to keep this information and to kind of rehearse it so you don't forget it. Okay. Let's say you're watching TV and you're paying attention to what's happening on the TV show. We've probably all been in a situation where someone's come up and they started talking to us. Now, you realise that you're trying to listen to both at once, but it's really, really difficult. And actually, you end up just paying attention to only one of them. Yeah, so you may actually pay attention to the TV and you've missed what the person said, or you listen to the person and you've just completely missed what the TV said. Yeah, it's quite frustrating. Now this is because our central executive can only focus on one thing at a time. Yeah, it doesn't actually store information. So the phonological loop, this is where we are rehearsing sound-based information. Okay, it's made up of our phonological store, which is where we're holding the words we hear, and it's made up of our articulatory loop. Okay, now the phonological store by itself is often called our inner ear. Okay, this is kind of where we are listening to things. This holds the kind of sound-based information from the world around us, and it can pass information and take information from our articulatory loop. So just like articulate the ball game or about speaking, this here it's our verbal rehearsal system for our heard words. Yeah, so the information being passed from our phonological store is sent here to be rehearsed. It also applies, well, you can see, to scene words. When you're reading things, you are still actually silently rehearsing them. Okay, so it doesn't mean you are sitting there literally going over everything in your head over and over and over again. It just means that this will be doing it for you. Okay, now it's got a bit of a weird kind of duration and capacity kind of amalgamation. It can hold as much as we can rehearse within 2 seconds. Yeah, certain words obviously are quicker to say, certain words take longer to say. So we're going to look at this a bit more next lesson, but you see that actually it does work out quite well. Okay, but we won't go too much more into that. Some students tend to get a bit confused with terminology here, so I always remember it goes loop, store, loop. Phonological loop is made up of the phonological store and the articulatory loop. Okay, if you tell me in your answers that it's made up of phonological loop and the articulatory store, then that's all a bit backwards, you have low accuracy, and your answer loses marks very quickly. Okay, so be really careful. Loop, store, loop. Okay. So our visuospatial sketchpad. This is where we are kind kind of sorting out our visual and our spatial information. Okay, so it's looking at what things look like, yeah, and the physical relationship between objects. So one of our spatial memory. So if I said to you, imagine you're in Hut 4 in a psychology lesson, you'd probably be able to do that. You can imagine what the room looks like, you can see it quite vividly, and you'd know exactly where you were. Okay. Now if I ask you to imagine standing up from your desk in Hut 4 and walking over to the front desk, obviously all my kind of teaching stuff is and where my computer is, okay, you could do that as well, because you can remember where everything was, how far away things were from each other, and that's the spatial information. Okay. This allows us, in a kind of a real-time setting, so it's a working memory, to orient and organise ourselves in the world around us. So you sitting there at home, you will actually be very aware, though you might not be kind of consciously aware, but your working memory will be aware of exactly where you are in relation to everything else around you. Yeah, you could probably close your eyes, reach out and grab your phone, yeah, because you still remember where it is, you still have that information in your working memory, in your short-term memory. Okay, but it also allows us to do things like a mental arithmetic. If I ask you to times 300 by 264, yeah, you could probably actually do this. And how you'd start working out is you'd imagine in your head kind of a very visual kind of piece of paper that you've written this kind of sum on, and then you start working out in your head just like it was on paper, step by step, number by number. Now what tends to happen though is if you overload this, because again it's got limited capacity, people tend to actually find that the early information they were working out tends to fade away. So you actually can't actually work out too large sums here. But it is what we're using for things like mental arithmetic, for map reading, any skill that requires both visual information and spatial information as well. So episodic buffer, this is what was added by Baddeley in 2000, and like I say, it's because he realised that you couldn't actually take any information from short-term memory into long-term memory with what the model just used to be. So it didn't actually used to have an episodic buffer, and as such there was no explanation for how we actually got anything to long-term memory. So like I said earlier, it is a kind of a general store for all this kind of information. It's visual and auditory information from the other slave systems in the model. And it takes all of these different things, the kind of the sounds that are happening, what was happening, kind of the visual detail, the spatial relationship between objects, all this kind of stuff, and it combines it with a sense of kind of time sequencing, is what he called it. So a sense of kind of timing to it, so you know what happened in what order. And altogether, makes an episodic memory, just like we look at in the types of long-term memory lesson. So this actually allows you to create a form of long-term memory that you can then refer back to at a later date. You can over time kind of detach the semantic meaning from this emotional context, and you can actually develop semantic memories from it through repetition of this information, or repetition of the actual action itself. You can actually develop procedural memories as well. So this is our working memory model. This is all the AO1 we have. Yeah, all these different slave systems, different components are all very important, so you need to make sure you know them all, and need to know as well what this model looks like. So make sure you do go back at the end of this and have a go at drawing out that working memory model. Okay, once you've drawn it out once, I'd recommend closing everything up, make sure you can't see it, and try and draw it from memory. Alright, you will have to be able to draw it from memory for the exam, just like our model, our multi-store model of memory. Okay, so in the next lesson, like I say, we're going to look at the AO3, going to look at the evaluation, the strengths and weaknesses of this model, and we're going to do some kind of knowledge checks, some exam questions, that kind of thing. Okay. Thank you very much, and goodbye.